Okay, so what we have seen yesterday, span, R span, ER span. Okay, now let us move to something known as FHRP, first hop redundancy protocol. What is first hop redundancy protocol? Robert, you have
It's
seen
where
that
you
thing?
use the virtual, yeah, it's where you use the virtual IP address for high availability, HSRP, VRRP.
So we have three types of first hop redundancy protocol. Why they are used? Okay, we use them for redundancy to reach over the any of the WAN or any of the internet connectivity. Like you can see in the diagram, I have a LAN connected over here, and what I did, so if I have only one connections, okay, through the ISP, okay, if I have one connection over here to the ISP, what happens if my this link goes down or if my this router goes down? What happens? The connectivity to the internet will go down. The ISP connectivity, the internet connectivity will go down. Okay, and what we need, suppose if we have two ISP connections also, okay, redundancy, we can have two ISP connections also, two redundant connections also for ISP, okay, with two different ISP or same ISP connections. But if my router goes down, if my link goes down, then I can move to the another link. If my router goes down, then what will happen? I need to replace this router. I need to replace this router, and I need to I need to add a new router, and it will take time. Till that time, my LAN user will not be able to access the internet, correct? So what we can do in this scenario, we can use something known as first hop redundancy protocol. Okay, FHRP. We can use first hop redundancy protocol in this type of scenario. So we have three types of first hop redundancy protocol. We have HSRP, we have VRRP, and we have GLBP. So let us see the difference between three of them. So this is something the different according to protocol features. Okay, so HSRP scope, it is a Cisco proprietary. VRRP, it is open standard, IEEE standard, open standard. Okay, so you can use HSRP on only Cisco router, same as GLBP is also used on Cisco router. VRRP you can configure on any vendor device. Load balancing is not supported by HSRP and VRRP, but it is supported by GLBP. Load balancing means if I have two redundant routers connected for my as my gateway, as my default gateway, one packet will move from here and one packet will move from here on this router. Okay, so this is called as load balancing. Multicast group IP address, so the address, the IP address that it uses to send updates to the neighbors, okay, or to the connected routers, that HSRP uses is 224.0.0.2 in version 1 and 224.0.0.102 in version 2. VRRP uses 224.0.0.18. Like these multicast addresses are same like our routing protocols multicast address. Like EIGRP has and OSPF also has some multicast addresses. These multicast addresses are used to send hello packets, okay, or keep to send the keep alive messages. Transport port number, it uses UDP port 1985. At VRRP uses UDP port 112, and it uses GLBP uses UDP port 322. Okay, then see how it will work over here, how the working goes. As I explained you, the working will go that if I keep two routers here on the devices on the LAN, I can give only one gateway. Only one gateway can be given. So what I did, I connected two devices, then my router one goes down. Then what I need to do, I need to go on all the devices and change the gateway, which will be very difficult for me to do. Okay, which will be very difficult for me to do, to go on. Suppose I am having thousands of users in my LAN, and to change thousands of default gateway, it will take some time. So what I will do, I'll use this FHRP thing, and suppose I'm using HSRP. So what HSRP will do? HSRP, we will configure a virtual IP address. This virtual IP address will be the default gateway on all the users, which will not go down. Okay, this IP address will be not assigned to any device. This will be a virtual IP address, and this IP address will be assigned as a default gateway on our LAN users, for our LAN users. Now, whenever a LAN user wants to go over the internet, it will go to this virtual IP address. Then the virtual IP address will check if my active router is up, then it will send the traffic via this active router. If my active router is down, then it will send it, or active router's link is down, then it will send it via the standby router. Okay, so virtual IP address is been configured by us. We will configure a virtual IP address. We will give HSRP or VRRP or GLBP a virtual IP address, and that virtual IP address will be the gateway for the users in the LAN. So we configure a virtual IP address, but automatically the devices will get a virtual MAC address. So they will use some group virtual MAC addresses. So HSRP will be using this as my virtual group. It will be 0000.0c07.ac, and this XX will be changed. This XX will be, it can be any number. Okay, it can be any number, but always HSRP configured device will be having this MAC address same. This as the same MAC address on all HSRP configured devices. On VRRP configured devices, this MAC address will be same. Only the last two bits will be changed. The last two digits will be changed, you can say. In GLBP, this will be same. So this is the group of virtual MAC address that they use. This is the group of virtual MAC address that they use in HSRP, VRRP, and GLBP. Then IPv6 support. HSRP has IPv6 support. VRRP does not support IPv6. GLBP also supports IP version 6. Got it? Then HSRP, VRRP, and GLBP. The roles of the routers in HSRP, we have one active router and one standby router. Okay, one is the active forwarder and one is the standby router, which will, once the active goes down, then the standby will come into charge and it will become as a active router. Now, how the election process is done, how they are elected as active, or something like how they are elected as active router. Okay, so the router with the highest priority will become the active router. Now the default priority on all Cisco's router is 100. Default priority on all Cisco's router is 100. Okay, so the highest priority will win the election and it will become the active router. Okay, if there is a tie, because all the Cisco's router will be having the default priority is 100. So if there is a tie in the highest priority, then the highest IP address on the interface will break the tie. It will be the tiebreaker. Highest IP address on the interface will be the tiebreaker. Okay. In VRRP, the concept changed to master router and backup router. Okay, we have master router and backup router. Here we have active and standby. In VRRP, we have master and backup. Okay, so the election process remains same over here also. Highest priority will be elected as the master router. If the priority has a tie, then the highest IP will become the tiebreaker. Got it? Then we have GLBP, active virtual gateway, means one active router. Okay, it will act as a virtual gateway. Okay, highest priority, the election process will be same, highest priority. Okay, highest priority, and you can say the second thing that is seen is my highest IP address. Highest IP address that it is connected. Got it? Now timers, there are different timers that are there over here. Hello timer is for 3 seconds. Hold timer is for 10 seconds. Hold timer, hello timer means each router, both the routers will send hello packets in every 3 seconds to each other, that I am alive. Okay, I am alive. Okay, I am alive. Okay. Then dead hold time means 10 seconds. If in 3 seconds this standby router will not receive the hello packet, it will wait for 10 seconds, and then it will take the charge as the active router. Okay, this is hold timer. It will wait for 10 seconds. Advertise time means hello time 1 second, and master downtime is some calculated with this formula 3 into advertise time plus Q times Q time. Okay, so this is calculated with this formula. Okay, master downtime or hold time you can say. Now GLBP has the same hello and hold intervals. Now we can change these timers also as per our requirements. We can change these timers. Okay, there is nothing that we cannot change. We can change these timers. Now the role of router roles over here are, in HSRP we have one active router and one standby router, as I told you, or one or more listening routers. One or more standby routers you can keep. Listening routers you can keep. In VRRP, one active router or one or more backup. Here it should be master router. Master. Here it should be master router. In GLBP, we have one active virtual gateway and up to 4 AVF routers on the group. Active virtual forwarder passing traffic. Now what happens in GLBP, like if we have a LAN network suppose, and here all the active, here all the, suppose I have kept all the routers over here. Now this router is my AVG router. AVG router, and all the other routers are my AVF router. AVF router. Okay, active virtual gateway means whatever the information from the LAN it will be coming, the information will be going to this router. Okay, and this router will be responsible to forward the information to all the other routers. Okay, whatever the things are, to be forwarded. So these are only forwarder routers, and this is something having the information about all the forwarder router. AVG router will be having all the information about the forwarder router, and you can keep up to 102 virtual routers in GLBP group per physical interface. Per physical interface, you can keep 1024 virtual routers. Understood? Now why we use HSRP? Okay, if I give some static route or floating default route, suppose I have internet connectivity. If I take an example, I have one router over here and it is connected to some two ISPs. It is connected to two ISPs. Okay, this is my ISP1, this is my ISP2, and this is my router, and here is my LAN users that are connected over here. Okay, so now what will happen? What we can do over here for redundancy, we can do a floating default route. Floating default route. What floating default route will say? Floating default route will say, if this is my primary path, and if my primary path will fail, choose the secondary path. Suppose this is some 8 Mbps link. Okay, and this is some 2 Mbps link. I'm just taking an example. 2 Mbps link. If my primary path fail, then switch to the secondary path. Okay, so we can give some two default route over here configured 0.0.0.0.0.0, and we can give next stop addresses, suppose 1.1.1.2, and the second next stop will be 2.2.2.2 suppose, and we can give over here a administrative distance value as 10 for the second default route. Okay, but what if my this router only goes down?
Hello, Qayyum.
Yes.
For a floating route, you give administrative distance or it's the metric?
Metric value, you can say administrative metric value.
Administrative metric value.
Administrative distance, you can see, you if you give the value over here, let me start the router. If I want to give the default route, static default route, sorry, floating default route, if I want to give the floating default route over here, the AD value will be changed over here. See, if I'm giving any route, suppose IP route 0.0.0.0, 0.0.0.0.0, and I'm giving the next stop is 1.1.1.2, here are my some values that I can give. Okay, so this is my first distance value, distance metric. This is also known as administrative distance. Okay, administrative distance metric for this route. What is the distance metric that you are giving? Okay, so I can give over here 10 if because by default the default route will be having the AD value as 1. The administrative value for static default route will be 1, correct? So what I can do, I can give a higher value over here, the distance metric value, administrative distance metric value higher than the default value. So if I make a administrative distance metric value higher than the default value, then that route will be considered as the second best route. Got it? This is the distance metric value. You can see over here. I can give a distance metric value over here. Understood? We'll study in depth about this thing also. Don't worry. Understood or not?
Yes, understood.
Now, as I was telling, if the link goes down, then we can switch to the another ISP. But what if my this router only goes down? There will be a single point of failure, no redundancy for the gateway. There is no redundancy for the gateway over here. So this is the reason we use something known as FHRP. Okay, FHRP, first hop redundancy protocol. First hop redundancy protocol. Got it? So we can see a practical one by one. So let us start with, so this will be my topology. We have already, Robert has already seen this topology. So here it will be as, we will start with my HSRP. So HSRP has the concept of active and standby. Active and standby. So I have already given the IP addresses. So my LAN is using some 1 dot network 192.168 1 dot network with /24. My gateway will be 1.100. First gateway will be 1.100 and the second gateway will be 1.200 standby. Okay, and virtual IP address that I'm using will be in the same network, that is 1.150. I'm using as the virtual IP address. Now here I'm using something like, this is my ISP connection, this is my WAN connectivity, where I'm using 1 dot network 1.1.1.1/8 and 1.1.1.2/8. Here I'm using 2.2.2.2 and 2.2.2.1/8. Okay, and on the ISP side I have some I have a loopback configured. So I'll take first the you can say I'll take this console of all the routers R1, R3, R2. R2 is my ISP's router. Okay, R2 is my ISP's router. This is my client. So I have taken a router over here working as my client. Okay, in my LAN that is connected. So if I see the IP addresses that are configured, if I show you, show IP interface brief. So on R1, I have already configured on fast Ethernet 0/0. I have already configured 192.168.1.100 as my gateway, and serial 3/0 that is connected to the ISP's router 1.1.1.1. On R3, my second gateway, show IP interface brief 192.168.1.200. Okay, and serial 3/1 that is 2.2.2.1. Okay, so these are my IP addresses that I've configured on my gateway routers. Then on the ISP side, show IP interface brief. I have configured both the 1. And 2. network, and I have configured a loopback. Now this loopback, let us consider there is some server that is kept over the internet, and we need to reach this server from the LAN user. Okay, so it is something like a server, virtual server that is kept over the internet. And if I come on the client, show IP interface brief, client is having an IP address as 192.168.1.1. So HSRP configuration I have shown at CCNA level also. We are not having the configuration at CCNA level, but that also I have shown the configurations. I'll repeat it again. Now I have some tasks to configure. Task to configure. First one, configure the basic IP addressing. Okay. Basic IP addressing. Okay. Now configure default route on R1 and R3 so that they can reach over the internet. To reach routes on internet, configure static route on R2, that is my ISP's router. You can say ISP's router, static route. Now you can use something known as NATing over here, but I'm not using NATing. Okay, back to LAN network on both the sides. So let us check. We have given the IP addresses. Let us check that if they are having any static route configured or any default route configured. Show IP route. So there is a default route configured on R1 side. From R1 there is a default route, and the next stop is 1.1.1.2. Great. Show IP route. There is a default route configured over here, and the next stop address is 2.2.2.2. Now let us check on ISP show IP route if I'm having any static route configured. So I'm having two static routes configured to reach 1. network. Okay, so these are pre-configured. I've configured the static route also. You can use something known as NATing also. Okay, over here I'm not using NATing. So I've configured these things. Got it? Now let me check the connectivity. I'll check whether my both the gateways can ping each other. Okay, 1.100 is getting pinged over here. Perfect. Now I need to configure, the task is I need to configure redundancy over here. So we will start with HSRP. Okay, so the first task is done. Now the task is to configure HSRP. So now I have some task I need to configure. Just give me a second. So we need to configure HSRP on R1 and R3 under fast Ethernet 0/0 interface. Okay, and use virtual gateway. I will use virtual gateway. Virtual gateway IP address I'll give as whatever we have selected over there, 192.168.1.150. Okay, this will be the virtual IP address /24. Now the second task is I'll make sure that R1 becomes the primary. Primary means it will become the active router. Okay, primary becomes the primary and R2 as backup, or you can say standby. Okay, now active gateway, whatever the active gateway will be there, or you can say R1. I can give you over here R1. Priority will be 120. We'll set the priority of R1 as 120, and the standby are left with the default priority. Default priority, that is 100. Okay. Now we can configure authentication also. If we want, we can configure authentication also between the routers. Okay. So authentication between both the routers. Okay, both the routers, and it will be MD5 authentication, MD5, and I'll use some password as Cisco. Password will be Cisco. Let us keep simple. Now standby will take up active role in a 5-second, in case if hello, in case if you can say 5 hello packets not received. Now, what is the meaning of this? What we have done, we have changed the dead timer to 5 second, or hold timer to 5 second, and the hello timer to 1 second. You can see 5 hello packets not received means 5 hello packet, 1 hello packet per second. If 1 hello packet is not received, then 1 hello packet is not received. Hello packet is sent 1 second at 1 second. Okay. So if this is the scenario, then the standby will take the not IP, it will take up active role. It will become the active router now. Okay. Now one more thing, the primary. So let us configure these things. We'll see the next thing. Okay, let me write it. The primary gateway should have the ability to resume the primary role once it comes up again. Once it comes up again. So whenever my primary router will go down, the standby router will take the role as my primary router. Okay. So we want that whenever the primary router comes up again in the future, it should take its active router role again. Okay. Understood? So what is the configuration that need to be done over here? So one by one we'll configure all the things, whatever we have seen. So let us go on R1. So as HSRP configuration will start on the interface fast Ethernet 0/0. HSRP, we are looking at HSRP. So HSRP configuration will always start by standby. Standby. Okay, standby. Then we have to select a group number. Any group number we can give between 0 to 255. So I will use a group number, suppose 12. Standby group number 12. Now we have different options over here. So first, what we need to configure? We need to configure a virtual gateway IP address. Okay, so I'll configure a virtual gateway IP address. So the virtual gateway IP address will be, I'll say I have an option of IP. Enable HSRP and set the virtual IP address. So I'll say IP is 192.168.1.150. Enter. Second thing is make sure R1 becomes a primary router and R2 as the backup. To make the R1 as primary router, I will change the priority value of R1 as 120. Okay. So what I'll do, I'll change the priority. All the commands will be starting with standby only. Okay. Now if I give question mark, I am having an option of priority over here. Priority. Okay. Priority can be set between 0 to 255. I'll give the priority as 120. Okay, this is done. Authentication between both the routers. Okay, authentication between both the routers. So I can make authentication also. See, I got a syslog message over here. Active router standby to active. Then the command is standby. Group number is 12. Okay, authentication. Authentication, I have MD5 plain text authentication also. So I will select MD5 authentication and it is giving me a keychain and key string option. I will use a key string. I'll use a key string, Cisco. Cisco is my key string. Standby 12 authentication, MD5 key string is Cisco. Okay. Now the next task is standby will take up active role in the 5-second. So I have to change the hello and the dead interval. I have to change the timers. Okay. So to change the timers, I have to say standby 12. And the option is given over here, timers. Now first it will ask for hello interval. Okay. If once you give the timer command, it will ask you for hello interval in seconds. So I'll say hello interval is 1 second. And then it will ask hold interval. Hold interval is for 5 seconds. Okay, so I have kept hello as 1 and hold as 5. Okay, now there is the last thing. The primary gateway should have the ability to resume the role once it comes up. Now what does it mean? Now suppose this router went down. This was the active router. This router went down. Now they exchange the messages, hello messages, and this router, standby router, did not receive the hello message for 5 seconds. Now what will happen? This will convert itself into an active router. Okay. Now after some time, suppose this this router came up again, or this link came up again. Anything happened. Now automatically this router will not take the charge unless I do any configuration. Unless I do any configuration, automatically this active router will not take the charge as active router. Okay, so by default there is no preemption. So I have to enable preemption over here. Preemption means whenever this router is up, give it the charge as the active router forcefully. I'm saying preemption. I'm enabling preemption. Okay. So I have to enable preemption over here for the last task standby 12, and I have to say over here preempt, preempt, preempt. Okay, this is the configuration. Do show history. This is the configuration that I need to do on my router. Okay, on the active router I need to say I have given these as my configurations. Now on the other side, on R3 standby, now the group number should be same, standby 12. I have to give virtual gateway over here also. I have to say standby 12 authentication. I don't need to change the priority. I need to keep it as default. Authentication is MD5C, bad authentication because I have not configured authentication. Okay, MD5 and key string is Cisco. Then timers, standby 12 timers. Okay, standby 12 timers 1 and 5. See, group state speak to standby. It became the standby router. Okay. Then what I need to do? I need to say preemption. I have to enable preemption over here also. Preempt. What does preemption say? Preemption says that if my interface goes down or if my active router goes down, you have to take the charge as the active router. But once the active router comes up again, you have to leave the charge as the active router and you have to give the charge to the that active router only. Okay, so if I go over here on R1 and if I check the configuration, show standby, I can get the configuration over here. I'm using group number 12. The state of the router is active. Two changes, last changes in this many seconds. Virtual IP address is this, and this is the virtual MAC address. See the virtual MAC address, it automatically took the virtual MAC address. We have not given any virtual MAC address. Okay. Hello time 1 second, hold time 5 seconds. Okay, next hello will be sent in 0.14 seconds. MD5 authentication key string is Cisco. Preemption is enabled. Active router is local router and standby router is 1.200 with the priority as 100, default priority. And the priority of active router is 120, configured 120, configured as 120. The default is 100 only. Let us check over here also on R3. State is standby. Virtual IP address is 192.168.1.150. Virtual MAC address is this, active virtual router's MAC address. Hello timers are these. Authentication, preemption is enabled. Active router is 1.100 with the priority as 120. Standby router is the local router. Priority is of the standby router is 100. Default is 100. Okay. So this is the configuration of SHRP, sorry. Now if I want to reach suppose 12.0.0.1, I can reach from my client. R4 is my client. Let me trace route 12.0.0.1. It is going via 192.168.1.100, then 1.1.1.2. If I do it again it will go with the same gateway. Again it will go with the same gateway. Ping 12.0.0.1. Okay, I'll make the repeat count as 1000. Okay, to check the connectivities. So what I'll do before doing the ping, I'll make this interface over here. I'll come on this interface and I'll give the command as shut. So before giving ping, once I start the ping, so the ping is started and I'll make this interface as shut. Now the see, we have not stopped the ping. The ping did not stop. Only a packet got dropped, and the ping is still continued. The ping is still continue. It is still going on. Only one packet dropped. Okay, because of this link went down to switch from this gateway to this gateway. Only one packet went down. It is still working. The packets can be still sent. So 1000 I gave more very huge this thing, and it does not get aborted at my side. Okay, so it got aborted. So see, now if I trace route over here on R4, see where what it is using. It is using 192.168.1.200 as the gateway. Okay, what it is using 192.168.1.200 as its gateway. Okay, understood? If I see show standby, sorry, not here, show standby. This is the active router. R3 is my active router. Standby router is unknown because there is no other router. Default priority, preemption is enabled. Okay. So once I make this up, once I make this interface up, no shut. Now this router should take the charge as the active router. You can see over here, it took the charge as active router again. Show standby. This is the active router now again, and the standby router is 1.200. The standby router is 1.200 again.
So
Got it?
in this configuration, you actually set the priority on R1 so that it would be the primary, correct? That's why you set priority 120 because default is 100, and on R3 you left it as the default.
100, the default.
Okay.
Yes.
All right, I got it. Thank you.
But if I would have not given the priority on R1 as 120, R2 this R3 would have become the active router. Okay, because it is having the highest IP address.
Right, I get you.
Understood?
Got it.
Now we have seen this thing as redundancy, as a part of redundancy. Now, okay, so what I said that this link is down. Okay, so this link is down. How they will exchange? They will exchange. How they will talk with each other? They will talk with each other with the help of hello messages. Okay, hello messages. So they are sending hello messages. Now this link is up, suppose. Okay, this is not down. This link is still up. They are sending hello messages to each other. Now, what happened? This link is also up and this router is also up. But what happened? My connectivity over the internet goes down. My WAN link goes down. Then what I can do? My WAN link goes down. Still, this router will send hello messages because this link is up. It will send hello messages. Okay, this router, standby router, will receive the hello messages every 1 second, and it will say, okay, you are up. I don't need to do anything. But the packet is coming over here till here, and the packet is getting dropped over here. And the standby router is not knowing that thing, because we have not done anything for WAN connectivity. We have done for the gateways. If my gateway goes down or the link to the gateway goes down, then we need to switch to the standby router, and standby router should take the charge as the active router. But my link to the gateway is up. My router is going till the gateway, but the gateway is not able to send it over the internet. My WAN connectivity is down. What we can do? So here there is an option of tracking this interface. If this interface on my active router goes down, then the router should not send an hello message over here, or something they will do that it will leave the charge as the active router, and the standby router will take the charge as the active router. So we can configure something like a track object. We can create a track object over here to track the interface, to track the serial interface. Okay, so let us see the option over here. What we can do: interface fast ethernet 0/0. The command will start with same standby 12. Okay, here I am having a track option, priority tracking. Okay, so I'll say track. Now what you need to track? We have different options. What do you need to track? I need to track an interface. Which is the interface type? I need to track serial interface, serial 3/0. Okay, so what I'm saying, what I will do over here, if my serial 3/0 goes down, okay, if the WAN connection goes down, then what you need to do? You need to decrement the value of priority. You need to decrement the priority value on R1. Suppose the R1 is having the priority value as 120. Now what I will say, if my this link goes down, the WAN connection goes down, you need to decrement the value by any number that would be less than this value. Okay, so suppose I will give the decrement value as 30. If I make this value as 90, if now the output of the R1's priority value will be 90. Now R1 is having the priority value as 90, and standby is having the R3 is having the priority value as 100. So this will take the charge as the active router. So what we are doing, we are saying that we are keeping a track of this link, the WAN connectivity. If my WAN connection goes down, decrement the priority value by 30. Decrement the priority value by 30. It will become 90. And when they are sending hello messages, they will send the hello packets, and the hello packets will be including the priority and all the things. And now the priority is higher over here on R3, so it will become the active router now. Okay, so this is how we can track the, so suppose I will give it as 30 over here. What I'm saying, track the serial 3/0 on R1. If it goes down, then make the priority value decremented by 30. Okay, this is what I've configured. Now let us check how we can check interface serial 3/0. Again, I'll start some ping. This time I'll give 500. Okay, I can give 200 also to keep it small. 200. I'll say this interface is, I'll make the interface shut down. Repeat, shut down. See, my ping is still working. My packets are still being sent. Okay, only one packet got dropped in between. The packets are still sent. Okay, if I don't give this command, if I remove this command and if I show you, then you will get the things over here. See, this is my standby router. If I show you output on the R1, you can see the priority is 90. Configured is what? 120. State down decrement is 30. We are having a track object, track interface serial 3/0. And if this state is down, then what do we need to do? We need to make the value decremented by 30. Got it? Understood or not?
I get it. I can't replicate what you're doing on on my Eve. I don't know if it's my iOS version. I don't have the same commands.
The command is not working over there.
Not on mine. I have standby 12 track. I have to select the track number and decrement. I can't select serial for some reason.
So after the track, what you cannot do?
After track, I have to select the number 1 through 1000, a track object number. Whereas you selected
so
the
you need to
serial
create
interface.
a track object. So it is some higher version of iOS. So that is the reason it is directly supporting VRRP. Okay, that is something. First, you need to create a track object. Then you need to apply the track object over there. Okay, how you need to do? I'll explain you that also. Don't worry. When we will be doing VRRP. Understood, others? Any doubt? So see, R3 will be my active router now. R3 is my active router because it is having a priority as 100, higher than the this. Now once if my interface come up again, this router will again take the charge as the active router. This router is again the active router. Understood? Got it? Now see, if I remove this command, whatever command I have given, if I say if I remove this command, whatever command I have given over here, if I remove, and then if I make the interface serial 3/0 down, now see, this will be still my standby, this will be still my active router. It will not change the state because we have configured something for my gateways. We have not configured for WAN connectivity. We have not configured anything for WAN connectivity. Understood? We have configured something for my gateways. This is still my active router. And the packet will not go anywhere. If I make ping, the packet will not go. It is not going anywhere. I cannot reach the internet. I cannot reach the server that is kept over the internet. So whenever my serial connectivity goes down, I need to make sure that I have a track object created. Okay. You can do it in different ways. See, you can do it in different ways. Now I have selected the interface. You can select the default route also. Okay, what you can do. So suppose I have a task over here. I need to configure R1 to track the default route. I need to configure R1 to tag the default route. Okay. And make sure that you should be able to reach internet even if the default route goes down on R1. So first thing what I've done, I've created a track object for my what this interface. Now what I can do, now see this command will be working at your end also, Robert.
I actually had an iOS. I got them both running now, but I still want to see this.
No issues. You can see this thing. Now I have removed the thing do show IP route. If I see I have a default route configured over here. Okay. 0.0.0 0 via 1.1.1.2. Now if my default route goes down, then I need a track object. So what you need to do, you need to create a track object. Track. And suppose I am giving a number as 1. Track object, first track object. And I have different options. I can select any interface. I can track any list. Okay. I can track any router, RTR response time. Okay. Response time reporter, or I can track any IP. So I'll track IP and IP route. I'll track a IP route. If my default route goes down, okay, what I did, I am creating a track object. In the global configuration mode, I'm creating a track object 1, and I'm saying in this track object, you have to track this default route. And what you need to do, what you need to check, I'm not having an option over here. Okay, I don't need to give this command. This is the next hop address. I don't need to give IT route 0.0.0. See here I'm having, I can give a reachability command. If there is no reachability from this default route, okay, then I've created an object, track object 1, check the reachability of the default route. That's it. Once I created this, then I will go inside the interface fast Ethernet 0/0 and then I'll apply this standby 12 and I'll apply this track object 1. Track object 1. If my default route goes down over the internet, decrement the value of priority to 30. You can do it in this way also. Okay, if I say show run interface or show run pipe section interface track, in track, see I have created a track object for reachability of this default route and I've given standby, I've given this, I've applied it on the interface to decrement the value as 30. Okay, you can do it in this way also. If I see show standby active router, and you can see there is a track object created and state is up because we the interface is up, still the interface is up. But if you need to check, what you can do, interface serial 3/0, I can make the interface down. I can check with the ping command. See, some of the packets got dropped, but still we started with the, it is switched to the other router. Okay, some of the packet got dropped, but still it reached to the second gateway. See, now we can see over here, show standby. See, the priority got decremented by 90 over here. Track object 1, state of the whatever you have given in the track object 1, the state is down. The state is down, and so we have decremented the priority value to 30. We have decremented the priority value to 30. Got it? Understood?
One question: the track number itself is a global parameter. So if you specify track 1, you can't reuse track 1 for something else, right? You have to use track 2 or track 3.
Sorry, come again. The track object is what?
Yeah, the track object is global, so you can. So if I go into the interface, E0 or FA0/0, and I set track 1, well, then I want to go through and set the track from config T, from global configuration mode, as you did just a second ago.
Yes,
I'd have to use a different track number.
On the global configuration mode also, like I have done before. Like I can create a track object over here, track object 1, and I can say I want the interface to be tracked. Interface, which interface I need to be tracked? Serial interface. What is the number of the serial interface? I need to say serial 3/0. And what do you need to do? What do you need to do? If the line protocol of this serial interface is down, line protocol is down, then what do you need to do? If the line protocol, I need to check the line protocol over here now. If the line protocol is down of the serial interface, if this interface is down, so I can create this over here also, and then I can apply it on the fast Ethernet interface. Understood?
But if you were to do that, that would overwrite track 1 that you already created earlier.
Yes, it will override the thing.
I got it.
It will be working the same.
No, I understand.
Yes. Okay. No shut. This router will again become the active router. Anyone else? Any doubt? Okay. Now we can configure HSRP. We can configure HSRP. We can configure multiple groups in HSRP. Like if I want, I have some users. They should be they should be the I have some 50 users and I want for 25 users router 1 should be the default gateway, and for other 25 users the R3 should be the default gateway. Okay, so R1 should be the active for any, you can say group 1, and backup for group any number, you can say group 3, and R3 should be the active for group 3 and backup for the group 1. Anything you can take. Now we can give the active gateway for gateway priority as 120, and standby we can keep it as default. Okay, the primary gateway should have the ability to resume and all these things. We can do these things also. Okay, so you need to you need me to configure, or you will try it by yourself? I can do it quickly, no issues. If you want me to do, I can do it quickly.
Yes, please.
Okay, just give me 2 minutes. Okay, so tasks over here is okay. I will configure HSRP on R1 and R3 on fast Ethernet 0/0 interface. Okay, using some group numbers, GRO group number 1 and 3, suppose. R1 should be active for group 1 and backup for group 3, and R3 should be vice and versa, should be active for group 3 and backup for group 1. So this, why I'm writing this task, this will help us to remember all the things, what all things we need to configure. Okay, so active router or active gateway, you can say active gateway priority will be 120 and standby as default. Now the same thing, the primary router should have the ability. The same thing I'll copy over here. The primary gateway should have the ability to come up and just configure this thing. Same thing. Okay. And the last thing will be also same. You can say this thing configure R1 to track object or something. This will be same for all both of the groups.
And this is HSRP
HSRP.
version, HSRP version 1 or 2, or
Sorry,
is it version 1 or
version 2.
version 2?
Yep. Okay, so let us. What I can do, I can just stop all the routers so that the configuration goes away. Whatever we have configured till now. We'll be still having the IP addresses, show IP interface brief, because I have stored it in NVRAM. Okay, I've saved the configuration, so I'm still having the IP addresses. Still, I'm having the connectivity. If I will check, I'm still having the connectivity ping 12.0.0.1.
Yeah, Qayyum, can't we remove the standby and active configuration by just saying no standby?
Yeah, I can remove that thing also. No, there is no issue, such issue.
Okay.
Yeah, we can just give no standby. And we can remove the configurations. I've not configured the virtual IP address, and over here on the router, what I did, I gave the virtual. So, Robert, it was working at your end because
I
I
didn't have everything set up. I was trying to set it up in
okay.
Eve.
Don't
I
have
didn't have it all
DNS3.
done. I do have it. It's just on my other laptop.
Okay, no issues. Why it does not get exit over here? Show run. If I give the configurations over here, show run. See the default gateway over here I have given as 1.150. Okay, I have pre-configured this thing. I have not shown you in the last practical. Okay, now my task will go back to our task. Now I need to create two groups. Okay, so I'll go inside the interface fastEthernet 0/0 standby 1. IP will be 192.168.1.150. Okay, and group 3 will be having some IP as any IP address 160, you can say. Okay, so group 1 is having some IP address as 150. So I have to make this as my this as my active router for group 1. So I'll give the priority as 120 over here. I'll say standby preempt. I'll not change, I'll not give any authentication or anything. Okay, neither I'll change the timers. Okay, I'll keep it as simple. Now standby group number 3 and IP is 192.168.1.150. 160. Okay, standby 3 preempt, and nothing I want on this router, because this will router 1 will be my this router will be my standby router for group number 3. Okay, now I'll go on R3. This is my standby for group number 1. So first I'll configure for group number 1 standby 1. IP will be 192.168.1.150. Then standby preempt, standby 1 preempt. Okay, that's it. Exit, not exit. I need to give for standby 3 also. Standby 3 IP will be 192.168.1.160. Standby 3 preempt. Standby 3 priority value will be 120, because I want this to become the this should become the active router. Exit, do show history. Okay, given the IP address, preemption command, IP address, preemption and priority. Show standby. Now over here I am having two groups. Over here I am having group number 1 and group number 3.
So you set 2 virtual IPs, and group 1 being the primary on the left side, and group 3 being the primary on the right side. Router 1 and router 3.
Yes,
right?
so I'll take one more router and I'll show you the things. Okay, we have taken one router only. I'll take one more router and I'll configure the default gateway as 160. Okay, so one router will go via R1 and one router will go via R3 to reach over the internet. So this way we can do load balancing on HSRP. In HSRP, in this way we can do load balancing. Got it? You're asking this thing only, Robert, right? Or something else?
Nope. That's it.
Hello, can I ask one question?
Yep.
Yeah. The concept, we understand the concept and the configuration. However, I would like to know in which environment can we implement this? Because let's say a mini size network, can we implement, does it mean that we're going to deploy 3 routers, physical routers, to do just a simple redundancy, multiple redundancy to the ISP? Want to know, or it is deployed in a major enterprise, a major network? I don't know if you get my concept, understand my question.
I didn't got you exactly, sorry.
Okay, what I mean is that the concept, we understood the concept and the configuration. But my question is that in which environment can we going to implement this? For instance, let's take a mini size enterprise network. Are we going to deploy 3 physical switch and routers to implement this HSRP?
Why we need 3 physical routers? We can keep 2 physical routers and only one router will be working at one time. See, both
In
the
the
routers
topology
will
we
be
are
on,
having,
but sorry?
in the topology we are having 3 routers there.
See, this is my
Router
ISP's router, Internet Service Provider's router that is connected to my routers. This is my ISP's router. This is not my router.
Qayyum,
My
but if we are
ISP.
using only 2 routers, what is the
Okay,
use of
router
second
4.
virtual IP?
Okay, router 4 is
This
a
is my
computer.
client. This is my client. This can be a PC. I am just taking this as a router. Okay, this is my PC something.
Okay.
Hello,
Okay. In
Qayyum.
this case, then it's clear.
Yes.
If you're using only 2 routers, what is the use of using this 2 virtual IPs?
If I'm using 2 routers, what is the use of using 2 virtual IPs?
Yes.
So for load balancing purpose. If I have many clients over here, what I told you, if I have suppose 100 clients over here, and I don't want that all the clients should go via this router only. I want that 50 should go via this way and 50 should go via this way.
Okay.
So that is the way I'm using. So what I will do for first 50, I'll give the virtual IP as this as the default gateway, and second 50, I'll give the virtual IP address 160. The default gateway as 160. So that is the reason I'm using 2 groups. And for both of the groups, I'm using active and standby routers. For group 1, this is my active router. For group 3, this is my active router.
So hold on. How do you define that? Let's say if you're using virtual IP 1.150, it automatically goes in group 1.
Yes, because we will be giving on router, we will be giving on the devices, we will be giving the default gateway as 160. That's what I shown you over here. See, I gave the default gateway on R4 as 150. On R5, I will give the default gateway as 160. So automatically where the router will go if you want to reach the internet to 150, will go.
I'm not asking about that. I'm asking about when we previously did our configuration about the standby. It went into group 1 or group 2?
Previously, we have only created 1 group. We haven't created 2 groups.
Okay.
We only created 1 group. There was only 1 virtual IP address.
So the group number, it automatically takes up, or it is it?
We configure the group number. Configure the group.
Nilesh, I think
configure this thing.
on the client PC, you have to define, the VRR IP, the gateway IP. So if you put group 1 gateway IP, it will go via router 2. If
That's what I told. That's what I told.
VRR IP, it will go via router 3.
See, this is, I am defining inside the group. This is the group, standby group 1. And I am saying for group 1, this will be the default gateway. Okay, this is the virtual IP address that the group 1 will use. Okay, and whenever I assign this IP address as the default gateway, automatically they will be a part of group 1 only.
Okay.
Samjha abhi, Nikhil?
One question for you. I got it. So HSRP support load balancing?
See, it does not support. It is not something like we can do load balancing. Load balancing is something like we are using only one virtual group and we are doing load balancing. It does not support load balancing like
so
GLBT.
If a straight question comes in exam, HSRP support load balancing?
No, it does not support. It does not support.
So what we call this, what we are doing here?
This is something we are configuring. We are doing. You can say we are doing some extra configurations. Okay, by default it will not support load balancing. We are doing some extra configuration so that it can support load balancing.
Okay,
we are configuring it by default.
Okay.
Yeah.
Officially Cisco says it doesn't support.
It doesn't support. It doesn't support
load balancing, but this is just a workaround, right?
Yes, this is just something we are giving extra something. See, this is something out of our syllabus also. I'm just giving you this knowledge that if you want to do something like, you can do this thing also.
Yeah, this is a good, good exercise. Thanks.
Nowhere you will get this thing. In Cisco also, nowhere you will get this thing. Got it? Understood?
Yes. What's in the case that we have 2 ISPs?
In the case we have two ISP that I've shown over here. See why we are doing this thing, IKIS. I'm not doing if I'm having two ISP, I can have the connectivity with one ISP and second ISP. But what if our side we only have one router only, right? If our side we are having two routers and both the routers are connected to different ISPs, then there is no issue. But if our side we are having only one default gateway and this router only goes down, then what will you do? Understood my question?
Yeah.
Router goes down and the router is only this router is only connected to both the ISPs. And this router goes down, then what you will do?
The link will be down.
Sorry, the connectivity will go down. The internet connectivity
Yes.
will go down. What you need to do, you need to replace this router with new router. Until that, your clients cannot access the internet, which is not good. So this is the reason we use first hop redundancy protocol. First hop redundancy protocol. This is the reason. Got it? I guess.
Yes. Sorry. Yeah. I'm getting you.
So as I configured R4, I'll configure R5 also. One 192.168.1.2 supposed to 55 to 55 to 55.0. No shut. No IP routing. I'll make this router to work as a router as a PC. No IP routing. IP default gateway will be 192.168.1.160. Okay, this is what I am configuring on this router. Show run. Default gateway I gave is 160. Okay. Ping 12.0.0.1. I'm able to reach. If I see trace route, see it is going via 1.200. But if I go on R4 and if I check ping 12.0.0.1, trace route 12.0.0.1, it is going via 1.100. Understood? In this way, you can make the load, you can make it work as load balancing. We will study VRRP. We'll see the last VRRP practical, Pawan. Okay, then we'll stop. Okay, because this video, okay, no issues, because this video takes some time to get converted also. So that is the reason I need to stop over here. Not over here. I'll take it some VRRP configuration. I'll show you. Okay, so I'll say no standby 1 and no standby 3.
I have one more question on HSRP. Is it automatically version 2, or is there anything you have to do to say HSRP version 2?
See, it automatically selects the version 1 is default thing. As I see, you can see over here version 1 is the default version 1. Okay, it selects the version 1 as default. Whatever we have configured, by mistakenly I've told version 2. It is automatically selecting version 1.
What command do you do to set version 2? I don't need to see it. I don't know the command.
Yeah, I'm just recollecting that command. Just give me a second. There was one command. So see, this is something done on the Nexus switches. Okay, so the command. It uses 224.0.0.2. I told you, and the command was. Let me check. Interface fast Ethernet 0/0. Standby. Here it is. Standby version. Standby version 1 or 2, which you want to select. Okay, you need to go inside the interface and you can select the standby version which you want to select. Okay, standby version 1 or 2 which you want to select. Got it?
Got it.
Okay, so where was I? I was just removing the commands. If I see show standby over here, I have group 1 and group 3. On R3 interface fast Ethernet 0/0, no standby 1, no standby 3. So standby, no standby. I've removed the configurations. Show standby. I've removed all the configuration, whatever we have done. Now VRRP works same, but it is an open standard. Thus the things change over here is that the work change over here is we will be changing the active route. The active will be the master router and the other will be the backup router. Okay, we can configure authentication. And one more thing over here is by default preemption is enabled in VRRP. Okay, we don't need to enable preemption. So interface fast Ethernet 0/0. The command VRRP will be starting with VRRP and any group number. I will select group number 1. IP address I'll give IP as I'll give 192.168.1.150 virtual IP. The commands are same. I want that R1 should become the master router. I'll say the priority. See the master and backup router over here. The concept master and backup router. I want R1 should become the master router. I'll make the priority value as 120. VRRP 1. Authentication I can give MD5 authentication and I can use some key string Cisco. So every command will start with VRRP. Okay, now here if I give and VRRP over here, if I want to track the VRRP over here, okay, VRRP, if I want to track the serial interface, if I give track, here I will be having a option to create a track object that you were getting in the new iOS version, correct? This you were getting, right? Right, Robert? So we have to first create a track object, then we have to implement that track object over here. So I need to go in the global configuration mode. I need to create a track object 1 and I want that interface serial 3/0 to be tracked for what? For line protocol. If that goes down, then what you need to do? I will say on the interface. I'll say if my VRRP1 track object 1 goes down, then decrement the value by 30. Decrement the priority value by 30. See, I have not given preemption command over here. VRRP1, then I'll say IP 192.168.1.150 will be the IP. Then VRRP authentication, sorry, VRRP1 authentication, MD5 key string is Cisco exit. So it became the backup router. Previously, it became the master router because we have not done the authentication. So once we gave the authentication, it became the group member, and now it is the. So if I want to verify, I can give show VRRP command. I will get group number 1 over here. See, preemption is by default enabled. I have not enabled preemption. In VRRP, preemption is by default enabled. I don't need to give the preemption command over here. The priority is 100, state is backup, virtual IP address, virtual MAC address, and authentication is MD5. Master is this router with the priority 120. Master advertisement time is 1 second, and the master doubt time is 3 seconds something. Okay, if I go on R1 and if I check show VRRP, I can get over here preemption is enabled. See, by default, I will be having preemption enabled. I can give one more command, show VRRP brief. If I give master, this state is master, preemption is enabled. Yes, master address is this address, group address is this address. This is the virtual IP address. Okay, understood? If I try to ping from R4 and if I make the ping repeat as 200, and if I go on R1 and if I say interface fast ethernet 0/0, I'll make this interface down. Once I start the ping, I'll make the interface down. So see, automatically it will take some packets will get dropped, and automatically the second gateway will become the R3 will become my master router now over here. R3 will become my master router over here. Okay, if I see show VRRP, see this is the master router now. This is the master router. State is master virtual IP, and master router is 1.200 local router. Okay, preemption is enabled. So if I make this interface up again, no shut, this will become the master again. See, this became the master again. So VRRP. Understood?
Yes.
Any question, guys? VRRP. See, the configuration is completely same. Now we can see the track object also what we have created. If you want to see the track object configuration, interface serial 3/0. If I say shutdown, see this became the master. Show VRRP. This became the master now. Why it became the master? Because we have given the track object. If I see VRRP over here, it will give me the track object state is down. So decrement the priority value to 30. Priority value is now 90. Okay, configured is 120. Got it?
I have one question.
Yes.
It may not make sense, but I'm going to ask it anyhow. Can you have more than just 2 routers in a HSRP or VRRP group? So if a master went down, you have 2 backups, or is it only a 2 router scenario?
We can keep any n number of, we can keep 4 number of routers over here. I have shown you. You can see over here. 1 or more listening routers in HSRP. 1 or more backup routers. You can keep routers you can keep 3 or 4 routers as your backup routers. If one fails, then if second fails, third fails, then you can keep
Okay.
for redundancy.
And if the master fails, it looks for the ones with the highest priority
Yes,
for
with
the
the highest priority or the highest IP address, whatever is it's come.
I got
Okay.
it. Thank you.
Yep. Any other questions? Anyone else? Okay, so we'll stop over here for today. We'll meet tomorrow at the same time.